Okay, this is probably the most important part of the 1.4 notes. The last two examples are looking at what is called the difference quotient, okay? And the difference quotient is really comprised of three pieces here. So I'm going to highlight the three different sections, and I want you to think of this as these three components here, okay? This is really composition. Okay, at least this first part that I highlighted in yellow. Okay, and this, sorry. Okay, let's try this again here. I'm not sure why that crashed. Okay, so we've got these three pieces here, and we're just going to tackle this in three sections. This part here that is f of x plus h, that is composition. Okay, and right now it's going to kind of feel like what is the purpose in this difference quotient, but you're going to see when we start chapter 2 how this plays a really crucial role in calculating derivatives for calculus. Okay, so you always start out with a function that they give you, and then we're going to apply these three different pieces and put them together into this difference quotient. Okay, so I'm going to put our big fraction bar here for the fraction bar right here in the difference quotient, and right now I'm just going to focus on calculating f of x plus h. Now what that means is I'm going to substitute an x plus h into my function every place there is an x. So I'm going to substitute, I like to write out where the x's are with parentheses, and then I'm going to substitute an x plus h in there and an x plus h right there. Okay, so just to kind of keep things color-coded and highlighted so this is easy to follow, this part right here in yellow is me doing this f of x plus h. Okay, now after that, you'll notice it is subtraction. That's why this is called a difference quotient. So you're going to subtract from that the original function f of x that you were given in the problem. Now here's where you're going to have to be careful. There are three terms to f of x. So when you are subtracting f of x, you will at first need to put f of x all in parentheses so that in the following step, we can distribute that -1 from the subtraction sign to all three terms. Okay, so this part right here that I highlighted in orange, that represents me subtracting the original function f of x. Okay, then lastly, the denominator is just dividing by h. Okay, and again, I know right now what we're doing doesn't have any meaning, but it will in the next chapter. We just want to get the mechanics down of how to kind of do the math, and then we will definitely put some meaning and context to this in the next chapter. Okay, so I have made all three sections complete here, and so all we're left with is now we just need to simplify. Okay, so if we have any exponents, and you need to be very careful here, you're not allowed to distribute this exponent and make this x squared plus h squared. If you have addition or subtraction in the quantity, you actually have no choice but to write the x plus h down twice on your paper, and in the next step, we'll FOIL that together. Okay, I'm going to go ahead and distribute the -4. Okay. This +1 is coming from this +1 here, and then I'm going to distribute that subtraction sign, that -1, so that it flip-flops the signs on everything, okay? All right, so now I'm going to go back and I'm going to do this foiling part here where we distribute the x and we distribute the h so that we get x squared plus xh plus another xh plus h squared. And just while I'm at it, I've noticed that there's some things that are going to cancel, like this -4x and that +4x. I'm going to cancel those. Here's a +1 and a -1 that I can cancel. So I'm just going to cancel those out so that the only other two things that I'm going to write down here are this -4h and this -x squared. Okay. Now, if I look back here, I see something else that also cancels and something else that I can combine together. So here's an x squared and a -x squared. Those will cancel. And here I have one xh plus another xh makes that 2xh plus h squared minus 4h all over h. So there's one last thing we can do for this. The last thing we're going to do is I'm allowed to cancel this h as long as I take an h out of every single term here. Okay, so I'm going to cancel this h with that h, with this h, and with one of those h squareds, but I'm still leaving one of the h's behind. So if I cleaned that up and wrote my final answer for this would be 2x plus h minus 4. Okay, that would be the answer for this. Okay, so the key is that there's just a lot of sort of algebra involved with just simplifying what you have there. Number 12 is pretty tricky, and I want you to be comfortable with a problem like number 12. So again, I'm going to kind of highlight our different pieces so that you can kind of think of this as having 3 parts to it. It sort of helps tackle the problem if you break it down into these 3 pieces. Okay, so let's tackle the yellow part first. This is the composition part. We're going to plug x plus h into our function where that x is. Okay, so that's going to look like this. I'm going to put parentheses where this x is, and then inside the parentheses, I'm going to substitute an x plus h. Okay, so again, just to kind of keep things color-coded so it's easy to see what piece came from where, this is the f of x plus h. Now, for the orange part here, I'm just going to subtract the original function f of x, which is 1 minus x. Okay, I'm just subtracting the original function. That is the orange part. And then in the denominator, we're just dividing by h. Okay, I guess I didn't color code that part there. Okay, there, dividing by h. Okay, now the tricky part, that wasn't that difficult to do that initial substitution in the 3 pieces. The tricky part is simplifying this because we have this overall fraction, but then in the numerator, we have these 2 fractions that we're subtracting. Okay, I'm going to take you back to, I don't know, maybe elementary school. If I gave you a problem like this where you had 2 fractions and you were going to subtract them, you would have to get a common denominator. Okay. Now, a lot of times our common denominator is found just by simply multiplying the 2 existing denominators together. So if I want my common denominator to, say, be a 6 in this example that I made up, then what I would end up doing is I would have to end up saying, well, what would I need to multiply the 2 by to make it a 6? And whatever I did there, I'd have to multiply that numerator by the same thing. And then whatever I'm multiplying the 3 by to make it a 6, I have to multiply the numerator by that same thing. So I have 3 in this numerator and 2 in that denominator. Once these have the same denominator, when you combine them, you actually do not subtract the denominators. The common denominator is what I have here, but you do move across the top and subtract the numerators for an answer of 1/6. Okay, I show that to you because that's what we're going to do with these 2 fractions here in the numerator. I'm going to make a little note just up here that my CD for common denominator is going to be me taking these 2 existing denominators and multiplying them together. The x times the x plus h. Okay, now I need to make both of these denominators look like this common denominator. So I'm going to multiply this first denominator by an x so that it will look like this. But if I'm multiplying the denominator by an x, I have to multiply the numerator by an x. Over here, I would multiply this denominator by x plus h. So then I have to multiply the numerator by x plus h. Okay, so now I'm going to rewrite this. This is my big fraction bar that is right here. This h is the h I put down here. Now that these both have the same denominator, I should be able to write it as 1 fraction in the numerator over my common denominator of x times x plus h. Okay, Okay, and just like here, when we had the same two denominators, we went across the top and we did 3 minus 2. I'm going to go across the top here and write x minus, and then this numerator is x plus h. Okay, and I'm going to want to distribute that subtraction sign to the x and to the h here. Okay, so I'm going to go ahead and do that. If I distribute that subtraction sign, I'm going to have x minus h, and that's going to cancel out those two x's. Okay, now it's not considered great to have a fraction kind of stacked on top of another fraction. We have all these fraction bars here. It's kind of confusing to look at it like that. So what I would encourage you to do is I would encourage you to keep this fraction, the negative h over x times x plus h. It's up to you whether you want to distribute this x in or not. Okay, but we are dividing this fraction, which was my numerator here, by h. And let's go old school here and use this old division symbol with the 2 dots. Instead of putting a division bar and showing we're dividing it by h, let's write it this way, because when you have two fractions, this will be one fraction and I made this look like another fraction. When you divide them, you actually end up multiplying the first fraction by the reciprocal of the second fraction. Okay? Now, the reason that's helpful is because now this h will cancel with that h. It's kind of the same idea as if I say if I have a 2 and I'm going to multiply that by a 3/2, this 2 and that 2 cancel, leaving me with just the 3. Well, this h and that h cancel, so if I multiply across the top, I'm going to get a -1 in my numerator, and the denominator, you can either write it x times x plus h, or you can distribute the x and write it -1 over x squared plus xh. Either one of those two is fine. Okay, there's going to be several problems on the homework that are going to ask you to use this difference quotient, even some like this, where you're going to have to work through getting a common denominator, and at some point in the problem, you're going to want to